Hello everyone, this video is about verifying trigonometric identities. This video continues where we left off in the last video. I introduced how to verify trigonometric identities, and this section is a more difficult part, or more difficult problems than the very first one that I showed you. So I'm building upon what you've learned in the last video. Remember, verifying trigonometric identities, in short, means try to get one side equal to the other. Okay? Here are some guidelines, and it's supposed to help you out to solve these. First of all, work with one side of the equation at a time. It is often better to work with the more complicated side first. So every time you see an equation, it's always better to work with the one that looks more complicated. 2. Look for opportunities to factor, add fractions, square a binomial, or create a monomial denominator. So using any of these 4 steps or 4 tactics or skills is a way to simplify one side. 3rd, look for opportunities to use the fundamental identities. Know which functions are in the final expression you want. Sines and cosines pair up well, as do secants and tangents, and cosecants and cotangents. For me, as I told you in the last video, it's a lot easier if you make everything into sines and cosines. Which is what they say in number 4. If the preceding guidelines do not help, try converting all terms to sines and cosines. Then number 5 is one of those I give up all hope methods. Try something, even make an attempt that leads to a dead end gives insight. So a lot of these problems also, even for myself, I can't get it right the first time. There's also more than one way to solve this, so how I solve it may be way different than the way you solve it versus somebody else, how they solve it. So don't give up. Even trying anything will get you to where you need to be. So we're going to start off with number 1, and before I get to number 1, I want to start with just a little bit of review. Some of you may remember that there's one Pythagorean identity I want you to remember, and that Pythagorean identity is sine squared plus cosine squared equals 1. And that's the one I need you to remember forever and ever and ever. If you forget every other identity, that's the one I need you to remember. Okay? With that, there's 2 side Pythagorean identities I didn't mention last time. Sine squared, if I subtract cosine squared to both sides, is the same thing as 1 minus cosine squared. Right? If I subtract cosine squared from both sides, I get that. And in the other form, or if I do it the other way, if I leave cosine squared by itself, cosine squared is the same thing as 1 minus sine squared. So these two formulas or equations are based off the Pythagorean identity that I told you to memorize. Essentially, if you ever see sine squared, I can convert it into 1 minus cosine squared, or vice versa. Or if I see 1 minus sine squared, I can convert it into cosine squared, or vice versa. So these 3 essentially are the only 3 you need to know to solve all these problems. Okay? So hopefully that makes it easier for you. You can memorize this, you can write it down. I think it's very easy to memorize. So let's look at number 1. Number 1 says verify this identity. So I got secant squared minus 1 over secant squared equals sine squared. Remember, there are multiple ways to solve this. Some of you may notice there's a secant squared minus 1 that sort of looks like the identity that we did in the last video. But for me, what I'm going to do is convert everything into sines and cosines. First of all, I need to identify which is the more difficult side. I think most of you will agree that this side, the left side, is way more difficult or more complicated than the right side. So let's convert these into sines and cosines. Secant, as you remember, is 1 over cosine. And since it's squared, it'll be 1 over cosine squared minus 1. On the bottom, I have 1 over cosine squared. And I know you have a fraction divided by a fraction, so don't freak out yet. Okay, so far? So all I did was convert everything into sines and cosines. And because this is the side that's less complicated, I'm always going to leave this side. I'm never going to mess with this side. I'm never going to do any math on this side. I'm only going to focus on the left side. Now some of you may be confused, like, what do I do now? I have a fraction of the fraction, I'm confused, I'm scared, I don't know what to do. Well, you'll notice that within a fraction, 2 things. 1, I told you this yesterday in class, but if I have a fraction divided by a fraction, can't I just flip it and multiply? So the numerator stays like so, right? And I multiply by, or I flip and multiply, so I'm multiplying this by just cosine squared. Or technically cosine squared over 1. So see, I took this numerator and multiplied by the denominator flipped, so cosine squared over 1. Now, since I have cosine squared times this parentheses, I have to distribute this cosine squared to both things. You notice that if I multiply cosine squared times 1 over cosine squared, I get 1. And cosine squared times 1, I get cosine squared. And now, you'll notice, this looks very similar to what I just taught you about an offshoot of the main Pythagorean identity. Remember, sine squared plus cosine squared equals 1, but if I move the cosine squared to one side, and if you're confused, remember you could rewind the video or look back at your notes, but this means the exact same thing as sine squared, which tells me I have verified that these two sides are indeed equal. Okay? So that is how you solve for the, or how to verify an identity. Now looking at example 2, and this even tells you what we're going to do or what we're going to practice here. It says we're going to practice combining fractions before using identities. So the very first thing, you'll notice that this is the more complicated side. Okay, I have two fractions and whatever. It's already in signs, but this section, or this side, I know I just said you don't mess with both sides, but I need to convert everything to sines and cosines or else I can't tell if they're equal or not. So the very first thing I'll do is convert this into cosine. So remember, it's 1 over cosine squared, so that's why it's on the bottom. Now, on this side, and again, to give you the hint on how to solve this, anytime you have fractions, I need to combine them. That was also in the last video I showed you. So I need to combine these fractions. What I'm going to do is I need a common denominator. Okay, I can't combine fractions. I can't add fractions if I don't have a common denominator. So what I'm going to do you see how this has a 1 minus sign, this has a 1 plus sign? So what I'm going to do is I'm going to multiply this side by 1 plus sign, top and bottom. And I'll multiply the left side, or sorry, the right side by 1 minus sign, so it will have the same denominator. And this is a skill you should have learned and should know from algebra. So up at the top, I'm going to have 1 plus sign over 1 plus sign, 1 minus sign. And on the right side, I'll have 1 minus sign over 1 plus sign, 1 minus sign. So do you see how I now have a common denominator? I have a common denominator. So now that I have a common denominator, just like in the last video, I can combine the numerators, okay? Because they have the same denominator. Now I can just add across. I couldn't just add these right away because they didn't have the same denominator. But now that I do, I'll just add across. And you'll notice 1 plus s plus 1 minus s. You'll notice that my s's cancel. Agree? So I will get 2. And on the bottom, 1 plus sign, 1 minus sign. So somebody's saying, man, how'd you get that 2? Remember, when I add across 1 plus s plus 1 minus s, my s's will cancel and 1 plus 1 is 2. Now I'm so close to getting it to look like the right side. And I think you guys can tell what I'm going to do next. So I already have the numerators, the top parts, equal to each other. I need to get these two equal to each other. Any suggestions? If you got this correct, or if you made the correct suggestion, you notice that I could multiply this out. I could FOIL this. When I FOIL it, I'm going to get 1 minus s plus s minus s squared. Okay, and you'll notice that they're conjugates, and when they're conjugates, the middle term canceled out anyway. So I get 2 over 1 minus sine squared. And if you remember, it's one of the Pythagorean identities. Sine squared plus cosine squared equals 1. And 1 minus sine squared is the same thing as cosine squared. And now, I have both sides matching. Okay. So that's how you do that for combining fractions. I think we have time for one more. A little bit more difficult, so obviously we're increasing in difficulty. So this one says verifying an identity. So verify that this is true. So first of all, I notice that this left side is the more difficult one. And I know this is more easier. I also notice that they're not in sines and cosines. I mean, this one is, but these two aren't. So what I'm going to do is I'm comparing the sines and cosines. So this one will be sine squared over cosine squared plus 1. And I got cosine squared minus 1. And here I got minus sine squared over cosine squared, which is the definition of tangent. So you see how everything is in sines and cosines. Now I got a FOIL, and some of you say like, oh, this is really messy, and blah, blah, it's okay. If I multiply the first ones, and I'll use different colors, if I multiply the first one, okay, cosine squared times sine squared over cosine squared is just sine squared. Okay. This fraction times a minus 1 is just the fraction. One times cosine squared is just cosine squared. And then 1 times a negative 1 is negative 1. Okay, so far? All right. Sorry, I noticed I made one mistake. When I multiplied this sine squared cosine squared times a negative 1, this should be a negative. So my mistake, this should be negative. Right? So to repeat the FOIL, this fraction times cosine squared, give me sine squared. This fraction times negative 1 gives me negative sine squared over cosine squared. This 1 times cosine squared gives me cosine squared. And plus 1 times negative 1 is negative 1. Okay? Now, everything is FOILed. And you'll notice, and some of you may not notice, but look, this part right here already matches this part right here. That tells me the other three pieces need to cancel somehow. Well, you notice that I have a sine squared and I have a cosine squared. If I add the two together, do you remember what I get? Yeah, 1. If this is 1 and then I subtract 1, that just all cancels out. So I could do it step by step if you want to see like the whole thing, but this whole thing just turns into 1 minus sine squared over cosine squared. The 1's cancel, which leave me with just minus sine squared over cosine squared, which is exactly the same as the right side. So we're going to do more practice. Obviously, we're going to do more practice in class, but hopefully you guys get the steps. You are going to pick the most complicated side, convert everything into sines and cosines, combine fractions or FOIL or somehow to get the left side to look like the right side. Obviously, I'm here to help you. I put these videos so you guys can watch it or rewatch it or rewind if you are confused about something. Hope you all understand, and I'll see y'all in class.